Hey, seventh graders, you guys excuse me, have a test this week. So hopefully you have completed your study guide and you are watching my video simply to check the answers you have already solved on your own. That's the best way you can prepare to take your test this week. So make sure you come to class on time tomorrow. You're not allowed to use this study guide, but you are allowed to use your calculator. So come on time. You got to keep those cameras on while you're taking your test tomorrow. So if you have any questions, just send me a message through your inbox. All right, so the first one asks about the population. So when you read the problem, it says Mr. Collier just opened a candy shop. He took a random survey by asking every fifth customer to find out their favorite candy and recorded the results. So every fifth customer isn't the population. He wants to know about all of his customers, right? And so his survey consisted of him asking every fifth customer, because it would take a lot of energy and time to ask every single customer. So the population is all his customers. That's really what he wants to know about. That's why he's conducting the survey. As far as the sample, the people who asked the survey question to, it was every fifth customer. So that's the sample. It represents the whole population. Now, when you ask what is the size of the sample, you're simply going to add up these numbers over here. And I haven't done this yet, but I see 27 plus 33 looks like we have about 60. I hope I'm right. I did that really, really quick. If I'm not, let me know. All right, so it says if a store manager expects to sell 540 pieces of candy next week, which is the best prediction of how many Reese's they should have in the store? So we're going to do the number of people that picked Reese's out of the total that he asked, which I believe is 60. So then we would find out how many people chose Reese's out of a grand total of 540. So we could cross multiply and divide, or we could just say, well, I know that if I multiply 60 times 9, I get 540. So to get the top number, if we multiply, I didn't have my calculator ready. If we multiply 15 times 9, that's 135. And that's the same thing I get if I cross multiplied and I got 60x equals this big number, 15 times 540 is 8100. And then if I divided 8100 by 60, I would still get 135. So either way you do that, hopefully we all got the same answer. Number 5, which candy represents the mode? So what does mode mean, everybody? The answer that occurs the most. So in this situation, we would have Jolly Ranchers. And who doesn't love a good Jolly Rancher, right? Especially the green ones. Those are my favorite. So number 6, a media specialist randomly selected 100 students and asked them how many books they read in a year. Of those surveyed, 60 students read more than 20 books per year. So of those that she asked, 60 out of 100 read more than 20. So based on this data, if there are 1,200 students, so the grand total of 1,200 students, how many read more than 20 books? So here is our ratio or proportion, I should say. So what could we multiply 100 by to get to 1,200? Well, that would be 12, right? So 100 times 12 is 1,200. So 60 times 12 would be what? 60 times 12 is 720. Or I could cross multiply. I could say 100 times x is 100x. 1,200 times 60 would be 72,000. And then if I divided both sides by 100, I would get 720. So either way you do that, we find out the answer is 720. There's 2 different ways to do that, either cross multiplying and then dividing, or think, how do I get from 100 to 1200? I'm going to do the same thing to the numerators. Number 7, Mario's Pizza wants a survey to determine which pizza people prefer. Which method would provide a random sampling for Mario to use? He could ask all customers at Mario's. Well, that's not a sample, is it? That's actually, that's called a consensus if you ask every single person of the population. So all customers at Chuck E. Cheese, well, that doesn't even make sense, right? Half the customers at Mario's and half the customers at Chuck E. Cheese. I don't like that one. How about every 5th person at the mall? That would be totally random. Every 5th person you see, regardless of their gender, their race, their ethnicity, where they're eating at, what store they're in, that's totally random. So D is the best answer. All right, determine whether each sample is random or not and justify your answer. Joe wants to know the favorite sport of students in his school. He surveyed his what? Soccer teammates. Is that random? Not random, right? Soccer teammates probably like soccer. Teammates probably like soccer, right? Not random. Crystal wants to know the favorite type of social media for students in her school. She does an Instagram poll of all of her followers. Is that random? Not random. These people, I'm sure, like Instagram because where's she asking them? She's asking them on Instagram. She needs to survey not using social media. So she needs to do it in person because she's asking about social media, right? If she wasn't asking specifically about social media, then that could be a platform she could use, but this one does not allow her to do this and make it a random survey. All right, we have a double box and whisker plot here. So it looks like class A, they have low scores or attendance, whatever this is about, than class B. So let's look at number 10. Which of the following statements is true? The median attendance for A is greater than the median of B. Well, the median of A is here, the median of B is here, so that is not true. The median attendance for both classes is the same, but well, that's not true. 6 and a 14 is not the same number. The upper quartile for class A, so upper quartile is here for class, oh, I'm sorry, that's class B. No. The upper quartile for class A, is 14. Is the same as the median for class B. The median for class B is also 14. That is a correct statement. And then finally, the range of class A's attendance is less than, well, you can tell by how long that box is, it's going to be greater than class B. So D cannot be true. Number 11, compare the interquartile ranges of the two box and whisker plots. So let me get rid of this stuff. So let's just gonna do interquartile range of class A is gonna be 14. So the upper quartile minus the lower quartile, 14 minus 4. 14 minus 4 is 10. And then for class B, the interquartile range, we have 16 minus 12 is 4. All right, so let's see what it says. The interquartile ranges are the same. Well, that's not true. Where'd my pen go? There it is. All right, the interquartile range for A is greater than the interquartile range for B. That is true. The interquartile range for B is greater. No, that's the opposite. The interquartile range for both classes cannot be determined. No, that's not true. We already know what they both are. All right, number 12 asks about that double box and whisker plot. It says compare the spread of each box and whisker plot using measures of variability which are less variable, right? So we're talking about ranges. We're talking about range, overall range, and interquartile range, right? So class A, let's find out the range and the interquartile range. And then we're going to compare that to class B, the range and the interquartile range. All right, so let me change colors here. So the range for A would be 22, 22 minus 2, 22 minus 2 is 20. And we already know the interquartile range is 14 minus 4, which is 10, as class A. And then for B, we have 22 minus 10. So we're going to say 22 minus 10 is 12. So the range for B is 12. And the interquartile range, we already said, is 16 minus 12, which is 4. All right, now let's read the information here. It says class A's graph has more variability. Oh, no, it says which one has less variability. Which one is less varied? In other words, which one's data is closest together? Well, the range and the interquartile range for A is larger than, greater than both of those things for B, which means B has less variability. So we know class A and B, option A and B is not the right answer. So A and B cannot be the right answer because which one's less variable? It's got to be B. So is it C or D? Class B's graph, because it has the greater interquartile range. No, that wouldn't make sense. It's got to be letter D because it has the least range and the least interquartile range. So D is the right answer. I hope y'all are getting all these right. All right, here we go. Number 13. Below there are line plots showing the number of hats and scarves that ladies at the retirement center own. What's the difference between the median number of hats and scarves? So the median, so let's see how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23. If we have 23 numbers, imagine what would be the middle? Well, if we had 11 on this side and 11 on that side, that means that item number 12 is the middle, right? 11, 12 plus 11 more that's 23 numbers right there. You understand what I'm saying? So it's the 12th number. So if I wrote all these numbers out, 0, 0, 0, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, I want the 12th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Guess what the 12th number is? For hats, the 12th number is a 2. All right, you understand? And then there's 11 numbers past this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are my 11 highest numbers. All right, let's look at the scarves. Let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So what if there's 13 numbers? We'd have the first 15 numbers, and then we'd have number 16, and then we'd have the last 15 numbers. 17 through 31 is 15 numbers. So the middle is the 16th number. So I could write all these out. I could write 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, and find the 15th, or excuse me, the 16th number. But the way I'm doing it is a little bit different. I mean, it's a little bit easier is what I meant to say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then there should be 15 numbers higher than this dot right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, this is the middle dot right there. And it is a 3. So the difference is a 1. The difference in 3 and 2 is a 1. And it says justify your answer. Well, look at that work I've done. I've done work, and I could say that 3 minus 2 equals 1. So that is good work. All right, is that all, or do we have some more? Oh, we have some more. Let's see what these are. The tables below show the test grades for 2 randomly selected students in Mrs. Fabio's math class. So there's all the information. Based on the test scores shown, which student most often has higher test scores? Use 3 statistical, why can't I say this number? Statistical, oh my gosh, you guys, it's late. Use 3 statistical measures of center and 1 measure of variability. So measures of center would be median, mean, and center would be, how about mode? And then 1 measure of variability, we can use range, or we could have used interquartile range, okay? All right, so if I put these numbers in order, I would have 45, and then what? 80, and then what? 81, 84, 89, and 89. So our middle number is 1, 2, 3, 4, 5, 6. So it'd be halfway between 81 and 84. So it's going to be 82.5. So if I wasn't sure, I would add these 2 numbers together and divide by 2. But it is 82.5. All right, so our median for group A is 82.5, right? And then have you guys already figured out the mean? 45 plus 80 plus 81 plus 84 plus 89 plus 89 equals, divided by 6 is 78. So we have the mean is 78 and the mode is 89, and there's our median. And then the range, the difference between the highest number and the lowest number is 89 minus 45. 89 minus 45 is 44, equals 44. All right, so we've done that for group A or student A. Let's do it for student B. So let's put them in order. We have 50, 72, 78, 86, 88, and 90. So we want to know what's halfway between 78 and 76. I meant 86. So 78 plus 86 equals 164. Divided by 2 is 82. So our median for student B is slightly smaller than student A. Okay. And then let's find the mean and the mode. So for student B, I'm going to add 50 plus 72 plus 78 plus 86 plus 88 plus 90 equals, divided by 6 is 77 1/3. Keep losing my pen. There it is. 77 1/3. And then the mode, do we have a mode? We do not have a mode. So the mode for student B is none. So the question is, which student most often has higher test scores? So let's look at the means. So the mean for student A is a little bit bigger than student B, right? The range, I forgot to find the range. The range for student B is 40. So there's a smaller range on student B than student A, right? And so based on my information, the median for student A is a little bit bigger than the median for student B. So I'm going to say, based on the mean and the median and the range, there's not much difference on the range. I would say that student A most often has higher test scores. And even the mode for student A is 89. Although student B has a high score, 89 is actually the average between 88 and 90, right? So, but based on the mean and the median, student A has slightly higher, most often has higher test scores, okay? All right, let's look at part B. The grades for both students on test 3 are low. I agree with you. A 45 here and a 50 here for test 3. How does this average affect the 3 measures of central tendency and the range? So since both of these students have a low outlier, then what does it do for the mean? The mean, the outlier lowers the mean. What about, we talked about the mode. The outlier has no difference, right? What about the median? I mean, the median, since that outlier is a low number, I would say that if the outlier wasn't there, the median has been lowered as well. It would be higher without that low test score, right? So I would say the outlier lowers the median also, but it has the opposite effect on the range. Since that number is real low and we're subtracting the highest minus the smallest, the range, the outlier increases. That low outlier increases the range. It makes it much bigger. Okay. All right. I think that was the last one. I might be wrong. All right. It was, you guys. So tomorrow we're taking the test. So make sure you show up on time. You have your pencil, piece of paper for scratch paper, and your calculator. And you'll have to have your camera on the whole time. So I will see you guys tomorrow. I hope you guys have a great day.